Hello, my Algebra 2 students. It is day 3 of probability, and we are looking at the addition rule. So the first example will give us an idea of like how this is going to break down, and it's great review. So the first part of it, when it says, when a car is brought to a repair shop for service, probability it's going to need transmission fluid is 0.38. Probability it's going to need brake pads is 0.28. Probability it's going to need both the transmission fluid and the brake pads is 0.16. All right, let the event that the car needs a transmission fluid be T. All right, so T is that they need transmission fluid. And the event that the car needs brake pads be B. All right, fabulous. So when it says here, find the probability that a randomly selected car needs the transmission fluid or the brake pads replaced. Okay, there's two ways to do this. We can set up a Venn diagram, or we can set up what's called a two-way table. Let's set up the first stage. For a Venn diagram, we usually just put a big rectangle around it. And then because we have two categories, transmission fluid and brake pads, we're going to create two circles within that. So one being transmission fluid, one being brake pads. Where they overlap, that's going to be both. In terms of the two-way table, we can kind of get ourselves set up with a little rectangle, and then we'll come back to the details in a moment. Let's start with the first one. The fact that we are told that the probability of T, the transmission fluid, is 0.38. The probability of B, the brake pads, that's 0.28. And then the probability of both of these things, that's going to be 0.16. So in the Venn diagram, that part is the overlapping piece. So we start by doing this first. So the 0.16 goes here. The key detail when creating the Venn diagram is that when we say the probability of transmission fluid is 0.38, that full circle has to represent the 0.38. So I would subtract the 0.16 from it, and that's going to leave me with 0.22 right there. And that's what will go over into that part of the Venn diagram. And then do the same thing over here. When we say that probability of B is 0.28, that has to be the full circle. So remove the 0.16 that's already accounted for. And of course, you can grab your calculator if you need it, but that should be 0.12. The key detail with a Venn diagram is that the full diagram represents 1.0, all right? Because your probability should add to 1 total. All right, in terms of a two-way table, how we set this up is you are going to have the T and the B, but then you're also going to include not T and not B. So what I mean by that, the probability that you'd come in and need transition fluid, or that you'd come in and not need transmission fluid, right? And then along the side here, we can see the probability you need brake pads, and then the probability that you do not need brake pads. And then the last part, these are just going to be our totals. So I left a lot of space for the total over here, but that's okay. All right, so if we go through, the information that's being given doesn't change. So I'm still going to use this data over here. Probability of transmission fluid is 0.38. That's the total number of cars. So 0.38 goes down here. Probability of brake pads, go to the end. That's going to be 0.28. And then the probability they need both, that's the overlap right there, the intersection. So right here where brakes and transmission crosses, we put the 0.16. All right, here's the cool part. To fill in this table, a couple of things. Just like a Venn diagram, the whole thing is 1. The entire total over here should be 1. So where the total lines cross has to be 1. Everything else, the rows need to add to equal the total here. The column needs to add to equal this total here. So 0.16 plus whatever equals 0.28, or of course, you would just subtract. So if you do 0.28 minus 0.16, which we did down here, that's 0.12. Do the same thing here. 0.16 plus what gives me 0.38? Well, it'd be that 0.22. And now we have a couple more values to find. We need the row across the bottom to add up to 1. So if we do 1 minus 0.38, that's going to give me 0.62 down here. And then over here, same thing. If I go 1 minus 0.28, that'll fill in this gap. So that gives me 0.72 right there. And then the last detail, I can either go down or across. It does not matter. So if I do like 0.72 minus 0.22, that leaves me with 0.5 right there. And what that actually is, that's not needing brakes, not needing transmission fluid. If I come back to my Venn diagram, that would be kind of the leftover hanging on the outside here. So two different ways to organize it, same result for both. Right? How we then use this to answer the question says find the probability that a randomly selected car needs brake fluid or transmission or brake pads, or transmission fluid. So one or the other, or both. All right, that's really what that's talking about. And so if we need the probability of transmission fluid or brake pads, that means I'm either going to add up these three little details, the 0.22 plus 0.16 plus 0.12. And if we add all that up, that is going to give us 0.22 plus 0.16 plus 0.12, 0.5. So I can get my answer, excuse me, by adding up everything in here. If I had done the same thing on this chart, I would have been adding up, excuse me, the 0.16 right here, the 0.22 here, and then the 0.12 there, which is a little trickier to see. So the other way in which you could see this is to say, well, I want everybody that's getting the brake pads, that's 0.28, everybody that's getting the transmission fluid. But if I add this total and that total, what you'll see is that the 0.16 has been counted twice. So the other way to show this would be to add up the 0.28 plus the 0.38 and then subtract out the 0.16 that got counted in both of those totals. All right. So if I do that, 0.28 plus 0.38 minus 0.16, that also will give me 0.5. I know there's a little bit of a glare there, but hopefully you can see it. So two different ways to calculate. So what the heck was this? Well, this was the probability of brake pads. This was the probability of transmission fluid. And this was the minus the probability of both. Now I'm going to write that a little bit more nicely down here at the bottom. But what I can say is if I want the probability of, I'm going to go A or B. I'm going to make it a little more generic here. Then what that's equal to in notation wise, that is the A union B. That's the synonymous with or. That's going to be the same as if I add up the probability of A to the probability of B and then subtract the overlap because that part got counted twice. And the overlap, I'll write both there, but that's the intersection right there, or the and, probability of A and B. All right, so that is our rule for today. So sometimes we're going to use this and kind of take the pieces. Sometimes we're going to actually just apply the rule depending on what information has been given. It says you've got a small high school surveyed 52 of its seniors to find out about their plans after graduation. So that's not you guys just yet, but next year. They found that the following data was given and they wanted to analyze it based on gender. Right? So in this case, if we pick a student at random, we can place them into one of 4 events. All right. So you're either a male going to college, not going to college, or you're a female going to college, or a female not going to college. All right. Sort of that idea on the front page, like I said, all right, you're either going to college or not going to college. You could say male or not male, but in this case, it's just male or female. But you kind of get the deal. It's kind of got to fit into one or the other, so to speak. All right. For part A, what is the probability that a person picked at random would be female who is going to college? All right. So to be female and going to college, let's do a couple quick things. First of all, I'm going to call this M, call this F. All right. We're going to say going to college, we'll call it C. And then not going to college, I'm going to call that N, just to make things a little bit easier for my notations here. All right. So when you say, what is the probability that you're female and, or who is going to college, and says represent it with a union or an intersection, right? If you're female and you're going to college, like that's how I want you to think of it. Is it one or the other, or is it both? So in this case, we would want to represent this, all right, with the intersection. It's going to be both. All right. So they're both female and they're going to college. So when you can use that word and, we're talking about the intersection there. All right. So you can even write it out. You can say probability of female and college, or you can write it as F intersect C like that. It doesn't matter to me. Just make sure you write it in a way that makes sense to you. All right. So if it just said how many were females going to college, we'll go look in the chart. So going to college, given that you're a female here, we got, 13, easy, right? But when it says, what's the probability, you have to divide it by the total number of people. So it has to be the number of females going to college and then divided by the total number. So just as a quick little reminder. All right, well, if you don't have totals over here, let's make totals. So let's make a total column here, and let's make a total column here. So you're going to add across the row to create the totals here, add down the columns to get the totals here. So here we have 16 and 13, that's going to give us 29. 14 and 9, that's going to give us 23. If I add down 16 and 14 gives me 30. 13 plus 9 should be 22. Adding across here gives me 52. Adding down here, that also gives me 52, which is a good check. Otherwise, it means we messed something up. All right, so 52 is the total that we need. So that's the probability that I pick somebody who's female going to college out of that whole group. And if I divide 13 out of 52, that actually comes down to 1/4. Don't forget about the fact that you can just divide on your calculator. So 13 over 52, and then math frac that baby, and it'll bring it down to 1/4 for you. Okay. All right, let's do a couple other ones. What's the probability the person picked at random would be a female or is somebody going to college? All right, well, that's different. So female or going to college, that includes all the females, and then it also includes all the people going to college. So you have an option. You can add up the numbers within the chart. All right, so I'm going to show it one way. So the probability of being female or you're going to college is the union. All right. And then, excuse me, I can add up all the females, which would be the 13 and the 9. And then all the people going to college, which would be the 16 and the 13. But I've already included the 13, so I can just add the 16 to that. All right, so 13 plus 9 plus 16, so 38. And then out of the total, 52. And then same thing, divide and math frac, that'll give me 19 out of 26. If I want to use the rule though, what the rule said would be to take everybody, that's female, plus everybody going to college, and then subtract the overlap. So the probability that they're female and going to college. So just to show how you use the rule in this case, we added up all the females. There was 22 of them. We added up all the people going to college. There was 29. And then subtract the one little overlapping piece. So if you're going to college and you're female, that was the 13 right there. The 13 from over here. Right? So if I do 22 plus 29 and then subtract 13, there's that same answer of 38 out of the 52. So there's multiple ways to be able to think of it. One is not more correct than the other. It sometimes just depends on how much information you're being given. All right. If you got the chart, you can do it whatever way you want. Okay. When it says explain why the probability of F or C is not just equal to the sums, well, we kind of explain that right there. Right. It's simply because the people in the overlap got counted twice. Right. So the females going to college would get counted twice, right? And then what is the general probability law based on for part D? All that actually means is like, what's the rule that you're using? Well, you're using the addition rule. So it's the idea that the probability of A or B is equal to the probability of A plus the probability of B, and then minus the overlap of A and B. Ta-da! All right. Now down here, we said that's if there's an overlap. What if there's not an overlap? Well, what that's called, right, is saying sometimes you get stuff where we make sure we don't count anything twice. That's referred to as mutually exclusive, where there is no overlapping at all, right? So when there are no outcomes in common, so like the probability of A intersect B would be 0. There's nothing in the overlap. So like visually, you can think of it as like two separate circles where they don't overlap, right? Or you can think about it where they, overlap, but there's like nothing in here, all right? There's literally nothing going on in the middle. So it's however you want to think of it. Sometimes it's easier to think of the visual where like, okay, they don't overlap at all. But that's it for that page. Example 3, it's saying on a certain midterm exam, there's 7 A's, 12 B's, 3 C's, and 1 sad little F. Determine each of the following probabilities. All right, to figure out the probability of getting the F, you have to know how many total we have. So 7 A's, 12 B's, 3 C's, and 1 F. That's going to give us a total of 23 right there. All right, so what it's saying is if you randomly selected a student, what's the probability to pick the kid that got the F? It would be 1 out of 23. All right, probability of getting A and B. All right, well, the probability of A and B means that you would get both scores, and that's not possible, which means there's nobody you could pick that got both out of 23, or you can simply just put 0, right? Because you cannot get both grades. Whereas a probability of A or B, that can definitely happen, right? So that means we would add the probability of A to the probability of B, and then subtract out anybody that got both. But we just talked about the fact that nobody can get both, so I can kind of ignore that detail for this. Probability of A, there were 7 kids there out of the 23. B, there was 12 there, and so it ends up as 19 out of 23. All right, the probability of B or not A. All right, so technically, what we can look at this, it's going to look weird, but roll with me on it. It would be the probability of B plus the probability of not A, and then minus anything in the overlap. Okay, so the probability that you get a B, there was 12 kids there, so that's 12 out of 23. The probability that you did not get an A, well, if there were 7 A's, if we do 23 minus 7, that leaves us with 16 kids that did not get an A. But then when it says, what's the probability of both? Well, if you got a B and not an A, any kid that got a B did not get an A. And basically, every kid in this category is in the overlap. So you basically have to take out all the kids that got a B. Kind of a weird way to look at it, but either way, basically those kids have been counted twice. You would just end up with this. That's it. All right, last part. Are A and B mutually exclusive? Right, well, are they mutually exclusive? Meaning, are they completely separate, essentially? Well, yeah, they definitely are. Right? And the reason being that because a student cannot get both an A and a B on the same test. So there is nothing shared. There is no overlap there. This is just a good example of using the rule. So it's saying, it's talking about insurance companies. So we got Flow, like, Flow is. Flow's insurance, 56% of all the customers have insurance policies. 48% have home insurance. Oh, first one was, car insurance. These ones have home insurance. 18% have both. If somebody's picked at random, what's the probability that he or she has at least one of the policies? So that means the probability that they have car or home. So if we're saying or, that means that we want to add together, but then subtract anybody in the overlap. So the probability of having car or home is the probability that you have car insurance plus the probability that you have home insurance minus the probability that you have both. Because we don't want to count those people 2 times. They're just one person. So you have 0.56 plus 0.48 and then minus that 0.18. So if we do it on our calculator, 0.56 plus 0.48 minus 0.18 leaves us with 0.86. And now something cool actually would have happened in this question that would have tipped you off anyways. If you just do 0.56 plus 0.48, it'd be over 1. You can't have a probability over 1. So that would have hopefully made you realize like, oh, I'm counting people twice, or there are people in the overlap. I should probably get rid of that. And there you go. That's it. All right. For part B of it, so as part A, find the probability that he or she has neither one of the policies. All right. Well, if you figured out everybody that has at least one of them, then anybody left, the probability that you have neither, we'll say, would simply be 1 minus the probability that you have car or the home. Because this included everybody that has something. So 1 minus that would leave you with the people that have nothing. So 1 minus 0.86, that would leave us with 0.14.